Hey everyone, just a few quick things before we get started. Don't forget to sign the attendance sheet. It's just real simple. Just ask you 2 questions. Kind of looks like this. But that's pretty much it. Please enjoy. Hope you all learned something. Worksheet for session 11, aka where we go over linear and binary search. Also, if you haven't filled out the attendance sheet down in the description, please fill that out. Alright, so the first question I have up here is, what is the basic idea for linear search? So linear search is kind of in the name. What it does is it searches an array linearly in accordance with the indexes. So we could say that it searches the array in a linear fashion starting at index 0 and to index size -1. Because, arrays start at 0 and they go to size -1. So basically it starts at the beginning of the array and it goes all the way to the end. And as it searches, right, it compares each value of the array at the specified index to the value that you are looking for. Right, and if it's true, then it returns it gives you the index. And if it's not found, usually people have it print out -1 since there can be no -1 index. Okay, so the next question is, what is the basic idea for binary search? So what binary search does, and is actually very important, is that the array has to be sorted for binary search to work. And this is very important. I'm about to tell you why. Because in binary search, what it does is it takes the lowest value of the array and then the highest value, and then it finds the middle value using averaging, and then it compares the middle value to what you're searching for. If what you're searching for is lower than the middle value, then it will make the high value middle -1 and search the lower half of the array. If it's higher than, it'll search the higher half of the array. And if it's even to the middle, then it'll just return the even index. And so that's essentially how it works. And you can kind of see you get the binary, right, by 2, because it cuts the array in half each time it doesn't find the array. So let's put this in words. Okay, so binary search compares the middle value to the one you're looking for. If it's higher than, if the middle value is higher, it searches the lower half. If the middle value is lower, it searches the higher half. If it finds it, if the middle value is equal, right? Give the index number. And so it should always hit the middle value if the middle value is equal, unless the number's not in the array, in which case, like, it will stop when the lower bound is greater than the higher bound, or vice versa. Based on this next question, linear search is blank efficient in comparison to binary search. So based on reading these two descriptions I just wrote, we can see that linear search is, in a sense, like easier to code and easier to kind of understand than binary search. However, just because it's easier doesn't mean it's going to be more efficient. Actually, binary search is going to be more efficient because it is going to take less. Binary search is going to make less comparisons overall, most times. And so I'm just going to give a little example on how these will work, in a sense. So we're going to make our little array, just an array of 4. Okay, and just to make it simple, I'm just going to number it. We're just going to do even numbers. Okay. And so let's say you're searching for 6 right here. So what it's going to do is, let's start with linear search. So linear search will search this 0, search the array 0 next to like, is 2 equal to 6? It's not, so it'll move on to the next one. And then it'll say, is array of 1, so 4, is it 4 equal to 6? And it's not, so then it moves on to this. It says, is array of 2, is 6 equal to 6? And then you'll be like, yes, okay. And then so we should give back the index of 2, or however you're using this search. And then so what would happen in binary search, though, is it'd take the lower bound, which is 0, and it'd take the higher bound, which is 3, and then it'd average them together to create a middle variable. So 0 plus 3 is 3 divided by 2, which is 1.5, but there's no 1.5, right? It'd take an integer because there's no there's no double indexes. And so it'd be 1. And so it'd be like, is array of 1 equal to 4? So array of 1 is equal to 4, so is 4 equal to 6? And they'd be like, no. It's 4 is less than 6, right? So then it'd move this lower bound up to here, because we already checked this one. And then so it'd create a new middle, so 2 plus 3 is 5, divided by 2, 2.5, so 2. So it'd check this middle. This middle happens to be equal to the low, and you're going to get that when the arrays are smaller like this. And then so it'd be like, is array of 2, which is 6, is 6 equal to 6? And then that's yes, and so it should return 2. So just in the small array, you can kind of see that linear search, or binary search, only made 2 comparisons, while linear made 3. In real small arrays, though, linear search is probably easier, but with big arrays, it's best to do binary. Okay. So the next question is, what are the basic variables for linear search? So for linear search itself, we're going to need an array. So, this is kind of given that you need an array to search an array, but just to be safe, we're going to need an array with a specified type. I'll just put integer for this case. So an array, an index for the array, we'll also declare that an int, and we'll say a value for what you're searching for, right? Like if you're searching for the number 7, then 7 would be your value. And so this is pretty much it. If you even want to count array and index, you don't really need a lot of variables for linear search. Binary, on the other hand, you need a few more. And if you were listening earlier, I kind of went over what you need when I was giving the demonstration, and even in the description above, like here. So let's go back and read this actually. It says it compares the middle value. I should actually probably put the middle index. Right, of the array. Just to make it like a little clear. Anyways, so right here, middle index. So obviously we're gonna need a variable called middle, and if we're gonna put arrays up there, we might as well put them in here. So we'll have array, we'll have an index, and again, this should be pretty standard. And yeah, so then we need a value, right? If we're searching an array for a value, we're gonna need that in there. And then so yeah, we're gonna need a middle variable that says to create indexes, to create the index you're gonna be looking at, right? And then it also says, like, this is like a lower half and higher half here a lot, and it even says like here, lower bound and higher bound. So essentially, we're also going to need like a variable to keep track of the lower part of the array we're searching, and a variable to keep track of the higher part of the array we're searching. Okay, and so like if you wanted to use these in functions, which is pretty nice. What would the parameters be? AKA, what would you have? Like if you typed in int linear search, what would be your parameters? AKA, what's in the parentheses? So we are going to start off with we need to pass the array into the function. So we're going to have an array. And we're also going to need a size, right, of the array. So we're going to do int size as well. And we also need to know what we're searching for. So int value. So this is kind of the exact same variables that we used as the basic variables. But this is essentially the parameters you would use right here. Okay, and so what parameters would you use for binary search? So we can do that same thing. And so you can see that, okay. So you can see that there's a lot more variables here than here, but in actuality, the parameters are going to be the same because the middle, lower, and higher are all going to need to be calculated with inside the function itself, and it won't actually be known in main. Oh, so yeah, so these are the parameters. Well, and now here comes the fun part. We get to code linear search and binary search. Now, again, it won't ask you to code these specifically, but by knowing how to code them, I feel like you get a better understanding of how it works. Plus, linear search is real easy, and so is binary for the most part. It's a little more difficult than linear, but it's just useful to know how to code these. Okay, so we're just going to start. We're actually just going to copy this because I don't want to retype it. Anyways, so we're going to copy this, and now we are going to create the actual function itself. And so if we can remember, the basic idea was to go through the array one by one. And so we have to traverse through an array. We have to go through an array. So the first thing you should automatically think of is, oh, I need a for loop. And if you did, you were right. We do need a for loop. If you didn't, that's okay. But just know, 99% of the time, if you're going through an array, a for loop will probably be necessary. Okay, so we'll have for int I is equal to 0. Does array start at 0, while I is less than size I plus plus. And so, it's I put less than size because I won't actually get to size. It will become size minus 1 at the max, which is perfect because that is where the array ends. Okay, great. And so now we have a for loop that'll traverse through the array. So this is going to go through the entire array. The only thing now that we need to do is compare the actual array element to the value. And so we're comparing something. So bam, we need an if statement. You should always use an, I'm hesitant to say always, but 90% of the time, if you're comparing something, probably use an if statement. Okay, so if array I is equal to the value, then we can have it return I. And so essentially this is going to return the index, and so it's going to tell us where in the array this value is stored. Okay? And let's say we weren't in, let's say we were doing this in main because you didn't feel like making a whole function or whatever. So let's pretend like this was in main for a second. Actually, we're gonna just do if you just wanted to be main, and then let's pretend you had a bunch of code here and a bunch of code at the bottom and a bracket. And then inside you wanted to have it in there to search, because this is still linear search even if it's not its own function. Instead of return I, because that's where it'd be in main, if you just have a break statement, it will break this for loop, and then I will still remain the same, although you'd probably want to declare it outside the for loop if you were going to be using it. So later in the function. So you probably want int I over here. And then that's how you get the index to be used within main.